The last section in chapter 7 that we're going to cover is 7.7, and this has to do with base E and natural logarithms. I'm going to show you on your calculator where those things are, but first we need to talk about what it means. And this is on page 1144 in your book. But you know, we know numbers like pi that go on forever, and square root of a number that's not a perfect square goes on forever. E is an irrational number. The value of E is 2.71828, and it keeps going. And it's known as the natural base. And whenever we have an exponential function with base E, it's called the natural base exponential function. So what I want to show you on your calculator is a couple things. So you can actually see what the value of E is if you wanted to check this out. So on your calculator right over here, so right below the log button, you see this button. This is actually ln, and it stands for the natural logarithm, and it's in Latin. That's why the L comes first. It's like logarithm naturalis or something like that. But notice right above it, you see this e to the x button. If you press that button and you put a 1 in there, so it'd be e to the first, and then hit enter, you'd get that number, that 2.7828, whatever. So if you wanted to try that, go ahead and try that just to prove to you that e actually does represent a number. We're going to get into when we use these things here in a minute, but I wanted to show you, again, some other things on your calculator because you're going to need to use them. So talk about a little bit more of how we could use E. And all we're asking to do here, and we've done this previously and earlier in the chapter, we rewrote these exponential equations in logarithmic form. So that's all we're doing here. We're not solving anything for now. We're just going to change it into logarithmic form. And if you remember, the base becomes the little number, the power goes on the other side, and then the answer goes in next to it. So if I wrote this in logarithmic form, this would be log base E of 8 equals the power x. Okay, just what we did before, rewriting it from exponential form into logarithmic form. Here's where the change comes in for 7.7. We don't write log base E. Okay, we don't write that. There's another way to express that. Now, if you want for a little while to write it out like this first, you can. Just know that the log of base E is the natural log. Okay, so that ln button on your calculator stands for the natural log, and that is log base E. And so just like in the last section where we don't write the 10 for the common log, we just write the log without the base. The same thing is true for the natural log. We don't write it when it's base E. Like I said, if you want to work through it that way first to arrive at this answer, you can. But eventually I want you to be able to transition from here to here. It doesn't have to be right away. So let's look at B. Same kind of idea. The base is E, which means we're talking about log base E, which means we're talking about the natural log. Then it's just a matter of deciding where the 5 goes and where the x goes. So go ahead and pause it, give it a shot, see what you get, and we'll come back to it. Alright, so in this case, since it's base E, we're talking about the natural log. The power is 5, so the power goes on the other side of the equals, and the x goes next to the natural log. So this is the natural log of x equals 5, which is the power. Remember, this means log base E. Okay, so just like we did earlier in this chapter, we're going to go the other direction too. I'm going to give you it in logarithmic form, and you have to put it in exponential form. So here are some of those. Okay, so I have logarithmic form here. Natural log of x is approximately equal to 0.7741. If you wrote an equal sign instead of the approximately equals to, that's totally fine. I'm not going to get hung up on that. And then this one over here, the natural log of 10 equals x. So all you're doing is putting in an exponential form. So if you remember, okay, the base right here is E. So it's E to this power equals that. Okay. So in this case, this would be e to the 0.7741 equals x. And that's all we're doing. Now, we could actually solve this if we wanted to. You could punch this in your calculator and get a value. And then over here, same kind of idea. Okay, so I've got e to the x equals 10. So just putting into exponential form. Okay, so that's a part of what we're doing in this section. The other thing that we're going to be doing in this section is using our logarithmic properties to take and simplify some logarithms. So for example, when it says something like this, in the earlier section, 7.5, we took our properties and we had one logarithm, we broke them up into multiple logarithms. In this case, we have multiple logarithms, and we're going to go the opposite direction. We're going to try to condense it down into one logarithm using our properties. See, the key here is that the only thing different about these is that it's the natural log instead of just some other log. The properties work exactly the same. So there's two things going on here that I want to point out. First, we have this number in front of the log, and we have two logs that are separated by a minus. So be thinking about which properties I'm going to have to use here. Okay. So my first move is going to be, I need to get this 3 inside here somehow. So how could I do that? Where would it go? Hopefully you're thinking about it and go, all right, this 3 has to come inside and become a power on the 10. Okay, just by using the power property backwards. So that gives me the natural log of 10 to the third minus the natural log of 8. And since now I have a log, and when it's subtraction, which property am I using? Yes, we are using the quotient property. So I can bring these two together in one log, putting the 10 to the third over 8, like that. And then, of course, I can simplify that, because this is 10 to the third, which is 1,000. 1,000 divided by 8, 125. And that would be my final answer. So all I did is I used my properties that we already learned before. The only difference here is I have natural log instead of a log. And I use my properties the same way. So let's work on another one. And if you want to give this one a shot and try it first and see if it matches up, go for it. Pause it and then we'll come back. So same idea here. I've got a natural log of 40. I've got a plus. I've got two pluses, so I'm going to have to use my product property in here. But I have this 2 out in front, so that's got to get taken care of first. That's got to come inside. Okay, so that 2 moves in. So I didn't change this. The 2 moves into the 1/2 as a power. What is 1/2 to the second? 1/2 times 1/2 is 1/4. And then, since this is being added and this is being added, I can bring this together times this using my product property. So 40 times 1/4 times x. Now I can simplify this. 40 times 1/4 is 10. 10 times x is 10x. So I have the natural log of 10x, and that's as far as I can go with that. Now, we've got some other types of problems that we're going to look at. And that's going to be solving equations when my base is e and I have variables in the power. So this is going to be similar to solving those equations that we did before too. We're trying to get this variable out of the power to be able to solve for it. And since the base is e, instead of taking the log of both sides, eventually we're going to take the natural log of both sides. But let's pump the brakes on that because we're not there yet. The first thing you want to know about solving equations like this is the e term by itself first. So I need to get this e to the negative 2x by itself first. Okay, which means this minus 5 needs to go and this 4 in front needs to go. So what do you think my first move is going to be? Well, hopefully you said add 5 to both sides, because then I'll have just the 4e to the minus 2x by itself. So this, of course, gives me 8. This cancels out, and so here's where I'm at right now. I've got 4 times e to the negative 2x equals 8. Now all I've got to do is get this by itself, which means the 4 needs to go, and since it's being multiplied, the opposite of that is, hopefully you said division, so I'm going to divide both sides by 4, and then those 4's cancel right here, so I'm left with e to the negative 2x equals 2, And I did this off the site because I'm going to show you how I'm going to move from here. Because my next move, since it's base e and I need to get this down using my properties, I'm going to take the natural log of each side. The reason, again, that I take the natural log of each side instead of the log of each side is because the base is e, and I'm going to show you what happens here on the next slide. So this is all going to kind of move to the next side with the natural log of both sides. So here's what that is, okay? So the natural log of both sides, all right, so this minus 2x can come down in front using our power properties, okay? And now we need to talk about this natural log of e and what this really means, okay? If I was to rewrite this in logarithmic or exponential form, excuse me, this means the log base e of e, all right? So e to what power equals e? This is what this really means, okay? Log base e of e. All right, so here's what it really looks like. This is what this means. E to what power equals e? And of course, that's a 1. And the reason, again, is if I wrote this in exponential form, this would be e to the what equals e. And of course, any number to the first power equals the same number. And that's the same thing that's going on here. So all of that, the point of all of this, is to tell you that these essentially cancel each other out because I just get a 1 out of it. So what I have here now is negative 2x just equals natural log of 2. And so what happens by taking the natural log of both sides when I have a base of e, they cancel and that just goes away. So the e goes away. So now in order to get x, because that's our goal, right? We're trying to get x by itself, I have to just divide by negative 2. So here's where on your calculator where I showed you that natural log button is, you just type this in your calculator. Now again, like I told you for logarithms, when you press the natural log, it's going to give you one parenthesis. Make sure you close it. If you don't put it in fractional form like this. If you put it in fractional form, it's going to be fine. But if you use this as a division sign instead of a fraction, you've got to close the parenthesis around the 2 because then it's going to take the natural log of 2 divided by negative 2, which is the natural log of negative 1, which is not what we want to do. Okay? So be sure to close that parenthesis. Now go ahead and type that in your calculator and see what you get for your value. And you should have got negative 0.3466. So again, in this section, the only thing that's really new is this whole log base e, which really means the natural log, and the base of e. Everything else is the same. The properties are the same. How you solve the equations is the same. How you go from exponential form to logarithmic form or logarithmic form to exponential form. So that's all that 7.7 is. We've got another base, that exponential base of e using the natural log instead of the regular logarithm. And that's 7.7.